Keep your mask on. Then you have to make it up. So, what type of wave is this? Is it transverse or longitudinal? Which one? Transverse. What is one wavelength? What would be one wavelength on this wave? So one crest to another crest is one wavelength. It can also be the distance from one trough to another wavelength, or any identical portion of this wave. So this here, going up, not right there, but going back up right here, this would also be a wavelength. So this is a longitudinal wave. And what would be one wavelength on this wave? So from the center of a compression to the center of another compression is a wavelength. Or the center of one rarefaction to the center of another one. So this is called a compression. This right here is called a trough. This is called a crest. While this is called a rarefaction. I'm not sure on the proper pronunciation of this. It's rarefaction or rarefaction. Let's see. So pronunciation.
Rarefaction. Rarefaction.
Rarefaction. So rarefaction. All right, so far. You did not fun. You too, Elena. You're not. So, what are some examples of transverse waves? So, what are some examples? What are some waves that are transverse waves? So, water waves? No. So, radiation? How do you spell radiation? So, light. Another word for this is electromagnetic wave. That's not related. So microwaves, X-rays, so that would include microwaves, X-rays, gamma rays, plasma rays, and things. What's some other ones? Infrared, UV light. So any electromagnetic wave is a transverse. What are some examples of longitudinal waves? It, you can get a transverse or a longitudinal from strength. Sound wave is the best example. So if an earthquake has two waves, an S wave and a P wave. So which one is longitudinal and which one is, yes, so that'd be the P wave. And S wave will be transverse. It's the transverse portion of an earthquake, where an earthquake were to radiate outwards from this point, the ground moves up and down. Yeah. Whereas P waves from an earthquake is where the ground bunches up in different portions. Keep your mask on. Alright, so let's say that this from here to here is 10 meters. Now, wavelength is only for one wave. This is the complete wave, or it's also called a train of waves. We usually say wave is the entire thing, but technically a wave is only going to be one sub portion. What is the wavelength of this? So right here is the start. We were to go up and draw one wave. So this is one wave. Then this be another wave. And then this will be another wave. And then this will be another wave. So there is 1, 2, 3, 4 waves. So this would be one wavelength, which would be, since there's 4 waves in total, this would be 10 divided by 4. 2.5. So one wavelength, so a wavelength would equal 2.5 meters, because there are 4 waves, and 4 waves have 10 meters. So that is 10 meters per 4 waves. So that is 10 divided by 4 meters per wave. So 10 divided by 4 meters per wave are 2.5 meters per wave. And meters per wave is a wavelength. So one wavelength, or one wave, yes, it will be math, just like the homework. So one wavelength is equal to 2.5 meters. You can either say that the answer is 2.5 centimeters, or you can convert it. It depends on whether or not the answer is converted or not. Let's say that it takes, let's say it takes 5 seconds for the wave to go from here all the way to here. What would be the speed of this wave? So the wave started here, and so it went 10 meters. So the speed, the wave speed took 10 meters in 5 seconds. So that means its speed is 10 divided by 5 meters per second, which would be 2 meters per second. It traveled a distance of 10 meters in 5 seconds. Let's say that the height difference between a trough and a crest is 4 meters. What would be the amplitude? What would be the amplitude of this wave? So amplitude is the distance from this midline up to a crest. So the amplitude is this distance right here. So if the distance between a trough and a crest is 4 meters, then the distance between the midline to a crest would be 2 meters. So the amplitude would be 2 meters. It's also the same distance right here would be 2 meters. What's the frequency of this wave? So its speed is 2 meters per second. Its wavelength is 2.5 meters. So the frequency is equal to speed divided by wavelength. You'll have to memorize the equation. Frequency times wavelength is equal to velocity. And solving frequency is velocity over wavelength. So that would be 2 meters per second divided by 2.5 meters, which would be 2 divided by 2.5, which would be 0.8 hertz. And the period is 1 divided by frequency, or 1.25 seconds. We will have to memorize those two equations. You have to. I'm not giving them on the test. So if you see 10 waves pass by in 5 seconds, what does that tell you? Does it tell you the speed of the wave? What's the wave speed then? So you took 10 waves and divided it by 5 seconds. So that's equal to 10 divided by 5. Our units is waves per second. And that tells you 2 waves per second. Is this a measure of speed? Speed is in meters per second. Where do you see meters anywhere in that? This is frequency. Frequency tells you something occurring every second other than meters. This is a measure of frequency. Frequency, so waves per second, cycles per second, crests per second. This is frequency. So if you see 10 waves pass by in 5 seconds, you can extract frequency of the wave. Elena, keep your mask on. So if I told you that the wavelength is 2 meters, what would be the speed of the wave? So speed is equal to frequency times wavelength. So frequency was 2 hertz, wavelength is 2 meters, thus the speed is 4 meters per second. Another way to solve this is if you see 10 waves, each wave is 2 meters, that means the entire 10 waves. So again, you're saying 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10 waves. Each one is 2 meters. This is 10 waves. Each one is 2 meters. That means this total distance is 20 waves. And we saw all 10 waves pass by in 5 seconds. So 20 waves, or 20 meters, is the length of all 10 divided by 5 seconds. Also gives you 4 meters per second. This is actually how this frequency and wavelength come out. This is a different way of solving it. What is Doppler effect? So the Doppler effect is the apparent change in frequency due to the relative speed between the source of the wave and the observer. So it's the apparent change in frequency. You hear it emitting two different sounds, one when it's coming towards you and one when it's moving away from you. Elena, keep your mask on, probably. The definition of a wavelength is the distance between two identical points in a wave. We can also define it as the distance between two successive crests. We can also define it as the distance traveled in one period. So period can be defined as the time it takes to complete one wavelength. The time it takes for it to complete is the time it takes to travel the distance of one wavelength. Keep your mask on. You cover your nose too. Keep it properly. So what's the equation for velocity? So velocity is equal to frequency times wavelength. If I wanted to write this instead of using frequency and period, how could I do it? How can I write it using period and wavelength? So what if I wanted to replace F with T? So frequency is equal to 1 divided by period. So I can plug this in for F. F is 1 over T. So that would be 1 over T times wavelength. So then 1 divided by T, just like if you had 1/2 times X, that's the same thing as X over 2. So speed is also equal to wavelength over period. If I were to keep frequency the same and double the wavelength, what happens to the speed of the wave? If I were to double frequency, or no, if I were to keep frequency the same and double wavelength, what happens to the speed of the wave? So let's say that the frequency, and let's make up a number. Let's say that it's 2 hertz. let's say that the wavelength is 2 meters. So that would be 2 hertz times 2 meters, which gives us a speed of 4 meters per second, right? If I doubled the wavelength, so let's make this 4 meters. So this would be 4 meters. 2 times 4 is 8. So what happened to the speed of the wave? So if I doubled, so we go from 2 to 4 meters of the wavelength, the speed would double. So let's say that this distance right here is 15 meters. The distance from the trough to here is 5 meters. What is the wavelength? How many waves are there in total? Is there 3? So again, if I start here, this point right here would be the end of it. So this is one wave. And then if I were to continue it, this point will be another wave. And then if I were to continue drawing this would be another wave. However, it stops right here. So that'd be a half a wave. This would be one wave. And this would be another wave. So the entire, there are 2.5 waves here. 2.5 wavelengths. Probably the better deal would be, this is a wavelength. This is one wavelength. And this right here is another wavelength. So 2.5 wavelengths is equal to 15 meters. So that means one wavelength would be equal to 15 divided by 2.5. So that means 6 meters is one wavelength. So from here to here is 6 meters. From here to here is 6 meters. And this is a half. This will be 3 meters. So 6 plus 6 plus 3 is 15. 6 plus 6 is 12. 12 plus 3 is 15. So so this entire wave is 15 meters. One wavelength is 6 meters. What would be the amplitude? So again, amplitude goes from the midline up to a crest, so 2.5, or down to a trough, so 2.5. This number wasn't used to answer the wavelength. What does waves carry? What do they transport? What do they move from one location to another? The vibrations they put. No. They don't carry matter with them. They carry what? Energy. They transfer energy from one location to another. This whole time. So, I haven't covered this before, but I'll give you a definition of this as it's on the test. Pitch is another word for frequency. It's technically the frequency we hear. So pitch is the frequency we hear. The word we use to describe the tune or motion of something. So we say something is at a higher pitch, we mean that it's at a higher frequency. So if something is at a higher pitch, that means it's at a higher frequency. Loudness, what would loudness refer to? What property of a wave would loudness refer to? Thomas, keep your mask on properly. Speaking of this wave up here. So in a transverse wave, it refers to the amplitude. So how loud something is actually refers to the amplitude. For transverse waves, it's how compressed the regions are. So in a transverse wave, it's how high from midline. So for example, if you have something like this versus something like this, this is more compressed, so this is a higher amplitude. It really depends. For transverse wave, it's meters. The same thing as length, because you actually physically measure this distance. Usually, though, we would convert this into an energy, and the amplitude refers to how much energy is in the wave. We usually report amplitude as a measure of energy. For sound, we report it in decibels. It's a measure of how much energy in it. You can quantify. How much this is compressed by looking at how much energy it takes to compress the atoms together. Let's see, what is it decibel? So waves carry energy or transport energy between two different points. What they don't carry with them is mass or matter. So sound waves, for example, again going back up to that one image of a so we were to look at this image of like a sound wave. Again, the individual mass, the particles, they don't move along with the wave. They vibrate back and forth, but they keep vibrating back and forth. They don't actually move with the wave. So what's being carried is the kinetic energy. It's being transferred from one atom to another atom to another atom. The only energy is being carried along the wave. So a longitudinal wave, so if the wave is moving in this direction, for a transverse wave, the particles are vibrating perpendicular. And for a longitudinal wave, if this compression is moving in this way, then they're vibrating a parallel. Or if the wave's moving horizontally, this would be horizontal. If the wave is moving horizontally. So this wave is moving horizontal. The particles are moving vertical or perpendicular. Not spelled correctly. Yeah. So if something is moving up and down 5 times in 2 seconds, what does this tell you? What does 5 times in 2 seconds mean? Tell you frequency is 5 times in 2 seconds. So the frequency would be 2.5 hertz. So if I have a rope that's vibrating up and down here, it strikes a wall here. and it reflected that, how many nodes? So there will be 1, 2, 3, 4 nodes, and antinodes. So here, here, and here. So this would be the antinodes. 3. Again, antinode is where it vibrates or moves the most. And a node where it appears, where it moves the least. How many waves in total is this? So again, so this is one wavelength. And this would be another wavelength. However, we don't have the full wave, so from here to here is half a wavelength. So in total, it is 1.5 wavelengths, 1.5. This would also be called the third harmonic. Basically, how many half wavelengths there are antinodes. So if you were to see, for example, a galaxy far, far away, and it's supposed to be orange, but you see it as red, and let me do different. Let's say it's supposed to be yellow, and you see it, however, as orange. Is it moving towards you or away from you? It would be moving away from you because it's redshifted. So yellow is becoming more red, it's becoming orange. So if it appears more red, it's redshifted and moving away from you. If it appears more blue, so for example, if it's supposed to be yellow, but it appears green, this is shifting in and one last thing. So with maximum, so constructive versus deconstructive or destructive interference. So this would be whenever a crest and a crest line up to make a bigger wave. This would be when a crest and a trough line up to make a smaller wave. Yes, everything I said was going to be on this. Yes. I highly recommend y'all study for the test. Now, a lot of y'all failed the first two tests.